Hi everyone, let's continue. So last time we went over quite a lot of examples, and you can see the integral can be very hard. Yeah, we might need to use a lot of methods to solve. Today, let's continue. Part B. Let's look at this integral. Oh, you might say, I don't see a square root there. Did I give you a wrong problem? Actually, you can think of this guy is the square root of x squared minus 4 squared. So you can kind of think of there is a square root there. So let's try to use trig substitution. And actually this problem can also be used, we can also use the partial fraction, which we're going to learn in the next session, 7.4. Okay, so this problem we can use trig substitution or partial fraction to solve. Okay, so if we have square root of x squared minus 4, what is the setup? Well, that is 2 secant theta, right? And then who's the wife? I mean, family member of that? Secant theta is tangent theta. And then what is the dx? Well, the derivative of secant is secant theta tangent theta d theta. So far so good, everybody. And then now let's calculate the indefinite integral. So remember, we can view this as the square root square. So dx is 2 secant theta tangent theta d theta. X is 2 secant theta. Okay, next term is 2 this guy square. So 2 square is 4, and we have tangent theta square. So far so good, everybody. Ooh, 2 secant cancel, tangent cancel. So we have 1 over 4 integral of 1 over tangent theta. And what is 1 over tangent theta? Cotangent. Okay, how do we integrate the cotangent? We know we learn how to integrate the tangent, right? And we also have the formula for integral of tangent, integral of secant, integral cotangent, integral cosecant. But I don't memorize it. Well, it's okay if you don't memorize it, just solve it. Okay, solve it again. Remember, we're not going to provide formula sheets if you don't memorize. It's okay, solve it. Actually, I don't remember. I didn't memorize the integral of cotangent because I know I can solve it again and quickly. So cotangent is cosine over sine. Well, use substitution. Let u be sine theta, then du is cosine theta d theta. Ooh, this is integral of du over u. That is ln of absolute of u. So u is sine theta. Isn't it so quick? So see, I don't need to memorize it. Okay, because we can derive it very fast. So next, change back to x. So theta, secant theta equals x over 2. Secant is 1 over cosine, so hypotenuse over adjacent. Here, by Pythagorean theorem, x squared minus 4. So 1 over 4 ln of sine is opposite over adjacent. Yes, everybody? Okay, let's continue. Oh, sorry. It's not opposite over adjacent, opposite over hypotenuse. Yeah, so it's very important to check our answers. Yes. Okay, so now what is the definite integral? Okay. I don't have much space, so I just put I still have enough space. Okay, let me write it down. Okay, so dx x squared minus 4. Well, this is gonna be this guy we evaluate from 4 over root 3 to 4. So which means I plug in 4. 4 squared is 16. 16 minus 4, 12. Square root of 12, 2 and square root of 3. Over x is 4. Okay? And then minus when we plug in 4 over root 3. 4 over root 3 is this silly. So 16 over 3 minus 4 over root 3. So what is that? This cancel. We get ln of root 3 over 2 minus, okay, 16 over 3 minus 4. That is the same as 16 over 3 minus 12 over 3. So 4 over 3. When we take the square root of 4 is 2 over square root of 3. Ooh! Do you see this cancel? And we have, oh, this cancel too. We have 1/2. So, and furthermore, you know, ln, we can combine them together, but it becomes divide. So square root of 3 over 2 minus, so divided by 1/2. Oh, we can actually cancel it. So 1 over 4 ln of square root of 3. Do you note square root of 3 is like 3 to the 1/2? We can put the 1/2 in front. So we get 1/2 times 1/4, 1 over 8 ln of 3. So this is our final answer. So far, so good, everybody? So after we learn the next session, 7.4, you can come back to this example and use partial fraction to solve it and to see whether you have the same answer. Okay? All right, let's continue. Okay. All right, so let's see here. Again, this problem, even though we don't see a square root, but you can think of this as square root of x squared plus 36. How do you get to? Well, it means you cannot take the 4th power of it, right? So, by the way, this problem, you can also use the method of partial fraction to solve, which is gonna be the next session. Okay, so x squared plus 36. So our setup, x is 6 tangent theta, right? And who's the family member of, oops, okay. Who's the family member of tangent? Oh, that's secant theta, right? And dx is 6 secant theta squared d theta. And then the indefinite integral equals x squared 6 squared tangent theta squared dx 6 secant theta squared. And oh, this guy is like the square root to the 4th. So 6 to the 4. See, it's this guy to the 4th. So 6 to the 4th right here. And then we have secant theta to the 4th. So 6, we have 3 copies of 6 in the numerator and 4 copies of the 6 in the denominator. So we still have 1 copy of 6 in the denominator. And then secant square, and we cancel, we still get square. So we have tangent square over secant square. All right, what is that? You know, tangent is sine over cosine, right? Secant is 1 over cosine. Ooh. You see, this is actually 1 over 6 integral of sine squared. So far, so good, everybody? Yes. Why do I think of change it in terms of sine and cosine? Well, you look at this guy. The power of tangent is not odd, so it's not the first case. The power of secant yeah, it's 2, but it's -2. You cannot really split a secant square, right? Because it's in the denominator. So it's not case 1, not case 2. Then change it in terms of sine and cosine. So usually the sine and cosine are all the 3 cases. We have guidelines for it. So it's easier to integrate. So that's why if you get stuck, change it in terms of sine and cosine. So we try different methods and then until we find the one work. Okay? So what's sine squared? Well, this is the even power, so we use the double angle formula. This is 1/2 minus 1/2 cosine 2 theta. All right. And integral of 1/2 is 1/2 theta. And integral of cosine is sine 2 theta, also divided by 2 plus c. And then we have 1/4 theta minus 1/8. Oh, but remember the sine 2 theta? You want to change it back to trig functions with the angle, which is theta. Okay, so that's why sine 2 theta is 2 sine theta cosine theta. I hope you're familiar with the double angle formula. Okay? So everybody, please, 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 this session is hard, and I hope that you have mastered all the trig identities and then all the antiderivative formulas of trig functions. Okay? Next. So, oh, this cancel. We want to change back to x. Let's draw the triangle. Let's draw it here. So our setup tangent theta is x/6, means opposite is 6. Opposite is x. Adjacent is x. Is 6. Sorry. Hypotenuse, Pythagorean theorem. Okay, so what is theta? Theta is arctangent of x/6. And then we have the 4 sine theta, opposites over hypotenuse. Cosine theta, adjacent over hypotenuse. Plus c. And 1/4 arctangent of x/6. Okay, 4 times 6. Let's see. Okay. Oh, I make a mistake. It was 6. Why do I change to 2? Okay, so this is 6. Sorry. 6 times 2, 12. 6 times 4, 26. Sorry, 24, I mean. Okay. And this is 12. This is, we cancel, we get 12 again. So, we have 12. And now we have the 12 here. And the 6 and 12 cancel, we have 2 in the denominator. So it's x 2, but the square root times square root just give us x squared plus 36. And then plus c. Oh, sorry, this should be minus. Okay, so far so good, everybody. And this is the indefinite integral. Then our definite integral we evaluate. So x squared 36 squared. Okay, so we evaluate this guy. Okay, I don't want to write again. So we evaluate from 6 to 6√3. So we multiply by, so we plug in 6√3 in it. 6√3 over 6, that's √3. 6√3 to 6√3 squared. That's 36 times 3 plus 36. Minus, we plug in 6. Plug in 6, 1/2. Arctangent 6/6, 1. 6. 6 squared, 36. 36 plus 36, 72. Okay, now let's see. Arctangent, we look at the picture of tangent. Remember the x values of the arctangent corresponds to the y value of the tangent. So if it's root 3 was that angle, this is pi over 3, right? If it's 1 was that angle, that's pi over 4. Okay, so this is 1/2. So 1 over 12. And this is pi over 3. Okay, here, what is that? 6 root 3. Okay, so you can factor out 36. You get 3 plus 1, which is 4. So, let's see, 36. We have 6. And let's continue. So, minus 1 over 12. Arctangent of 1 is pi over 4. And then plus 72 and 6 we can cancel. 1, 12. Oh, 1 over 24. Alright, and okay, so what do we get? This guy and this guy we can combine together. So we have 112 factor that out. And the pi factor that out, 1/3 minus 1/4. Well, that's 4 minus 3 over 12. So 112. Oh, so this is pi over 144. So far, so good. Not so good. So, okay, pi over 12, 1/3 minus 1/4, right? So that is pi over 12, common denominator 12, 4 minus 3. So that's what you get, pi over 144. Okay, and then we have square root of 3, 2 times 4, which is, okay, let me make sure. Oh, okay, so, yeah, 2 times 4 is 8. 8 times 6, 48. And then plus 1 over 24. So this is our final answer. So far, so good, everybody? All right. Next. Ooh. Okay, more exercise. Just set these up. Set up the trig substitutions and the new integrals in terms of theta, but do not need to evaluate. Okay, so let's just look at the integrand. The first, we have square root of constants minus x squared. Which trig substitution we should use? Tangent, sine, secant, which one? Sine, right? A is 5 sine theta. Then what's the x? Well, 5 cosine theta d theta. Who's the family member? Who's the wife of sine? Cosine. Okay, and then plug in 5 dx. Dx is 5 cosine theta d theta. X squared. So 5 squared sine theta squared. The square root term is 5 cosine theta. Oh, you see these cancel. This cancel one copy. This is 1 over 5 integral of d theta over sine squared. So this is the simplified version, right? And how do you proceed? You can see 1 over sine is what? Okay, I don't want to go through the yeah. So 1 over sine is secant. So this is, cosecant. So cosecant squared. Well, you know, cosecant, integral of cosecant is negative cotangent, right? Plus c. And then you can find your, so look at the triangle, right? Let's see, sine theta is x over 5. Sine opposite over hypotenuse. So adjacent is 25 minus x squared. So cotangent is adjacent over opposite. So this is how we solve it. Oh, we actually solved the problem. Okay, it's okay, right? We can go over more. So next, let me change a different color so that you can see it's a different problem. Which color do you like? How about green? Okay, so x squared minus 16, what is x? Well, x is secant, right? And it's 4 secant theta. And then dx is 4 secant theta, tangent theta, d theta. And what's the square root term? Well, the square root term was the family member of secant, so there's tangent, right? And then our integral becomes 4 tangent theta, or dx 4 secant theta, tangent theta, d theta, all over x. X is 4 secant theta. 4 secant theta cancel. Oh, we have 4 integral of tangent square. How do you solve tangent square? Well, we don't have a formula for that, but we have a formula for secant square, and it's related to tangent square. Tangent square is secant square minus 1. So integral of secant square is tangent. Integral of 1 is theta. And what is that? So here we have secant theta equals x over 4. Secant is hypotenuse over adjacent. Right? So tangent is then opposite over adjacent. And then theta is secant of x over 4 plus c. And this 4 cancel. So far, so good, everybody? Okay, next. 4x squared plus 49. Okay, so here's 2x equals 7 tangent theta. Oh, I want to use a different color to indicate it's a different problem. So, what color do you like? Pink? How about pink? My daughter loves pink. So 2x is 7 tangent theta. And so x is 7 over 2 tangent theta. Well, then dx is 7 over 2 secant theta squared d theta. Okay, so what's the square root term? Square root of 4x squared plus 49 is 7 secant theta. Oh, be careful. This is just 7, not 7 over 2. Okay? The square root term is always a, and either cosine, tangent, or secant. Okay, and our integral dx is 7 over 2 secant squared d theta. And then this is like a square root cube. So 7 cube secant cube. And 7, so it's like we have 7 squared in the denominator. The 2 is also in the denominator, so 1 over 2 times 49 is 98. And the secant, we cancel the secant square, so we only have a secant in the denominator. Ooh, what happened? 1 over secant is cosine, right? Oh, integral of cosine is sine theta. And what do we have? Tangent theta is 2x over 7. So this is 2x, this is 7. This guy is 4x squared plus 49. So sine is 2x over the Okay. Square root of 4x squared plus 49. Plus C. So far, so good, everybody? Okay, finally. Oh, what happened if I just change the sign to minus? Okay, let's see what happened. You see, just a little difference. Well, it's completely different setup. The whole problem is gonna be different. So that's why this Trig substitution, you need to be very careful, especially the setup. If your setup is wrong, you don't get any points of the problem because you don't get anything that is correct. So be careful. After you set up, double check your work. So 2x is 7 secant theta. Well, x is 7 over 2 secant theta. dx is 7 over 2 secant theta tangent theta d theta. Well, the square root term is 7 tangent theta. Well, dx is 7 over 2 secant theta tangent theta d theta. The bottom is like a square root term, cube it. 7 cube tangent theta cube. So 7 and 7 cube cancel, 7 squared in the denominator and the 2 in the denominator, so still 1 over 98. Okay, so tangent and 2, we still have 2 copies, so it's secant theta in tangent square. Oh, what happened? See, the power of secant is odd, the power of tangent is negative, so change it to sine and cosine. Secant is 1 over cosine. Tangent is sine over cosine. What is that? You see the cosine cancel? So this is actually, well, this is actually the cosine in the numerator and sine square in the denominator. So far, so good, everybody. Oh, so we can let u substitution. Let u be sine theta, du is cosine theta, d theta. And this is 1 over 98. Integral of u to the negative 2 du. And that is u to the minus 1 over minus 1, so minus 1 over 98. U to the minus 1, so u in the denominator. And u is sine theta. Okay, and secant is 2x over 7. So that's the hypotenuse over adjacent. Then this is 4x squared minus 49. So sine is opposite. So 4x squared minus 49. Can you see what I write? Over the 2x. So flip the 2x on top. Plus C. So this is our answer. It might be challenging to look at my words. Can you read it? Okay, so anyway, I post the notes with the answers on the website. So hopefully you can click that and zoom in. Okay. You can see the setup is very, very important. If your setup is wrong, whatever after is going to be all wrong. And another thing, don't forget your baby dx. If you forget your baby dx, that will change the entire integral, the theta integral. Okay, and you can see the power odd or even, just the degree a little bit different. The methods we solve the problem is totally different. So that's why this session is challenging, and you need to calm down and be patient, be careful, check your answer in each step. So far, so good. And please continue to work on a lot of like homework problems, and I also assign extra problems in the textbook. You can work on those. So I hope that you can have more practice, especially for this session. Okay, it's hard, but as long as you work on more problems, you will start to get the feelings of it, and you get used to it. Okay, so that's it for today. Have a nice day. Bye.